I think this is a great opportunity to hand over to our first speaker, who's Christian Lawson-Perfect from Newcastle University. So Christian, over to you when you're ready.
Thanks, Michael. Thanks for the opportunity. So I'm going to give a talk about formative assessment with numbers in not very much time. So I work at Newcastle University, as Michael said. I'm the lead developer of Numbas. Numbas is an e-assessment system developed specifically for mathematics and statistics, and it's used for quite a few other subjects now, but really the focus from our point of view is mathematics. I'm not going to give an absolute beginner's introduction to it. I'll refer you to previous TALMO talks, which I think are recorded, or the Numbas website. And also, I'm not going to talk about the fundamentals of online assessment of maths, because I think most of it, there'll be a range of experience levels attending today, I'm sure, but I think most of us will have done some kind of online assessment in the past few years. The move to everything online during the pandemic meant that pretty much everybody had to do some kind of online assessment. So I'm going to assume some knowledge. I hope I don't lose you along the way if you've never seen this before and you came along just to see what's possible. The point of this talk is that a lot of the use of online assessment is for summative purposes, because in lockdown or earlier on, we needed to move our handwritten assessments online in a hurry. Or previous to that, one of the main drivers for doing online assessment was reducing marking load. It takes a long time to mark handwritten pieces of work, while a computer can mark things instantly. Or one of the other drivers for moving assessment online was randomization, for the purpose of avoiding plagiarism, of avoiding students copying off each other. And I'm personally not too interested in those. What I want to talk about is formative use, where I think online assessment can be really useful, and I don't think we do enough of it. So I'm going to show you some things you can do with numbers, because as I said, that's the thing I'm most familiar with. There are quite a few e-assessment systems, and there are a few of those aimed specifically at maths. So hopefully some of this will apply to other systems as well. Right. So I've always been keen to have Numbas as a system that is good for formative assessment. Because when you're using assessment summatively, quite often the model is this: it's that you show the student a question, they give some kind of answer, and you mark it as correct or incorrect, or somewhere in between, and produce a score. That score then goes off to your grade book or whatever. And the point of the assessment is to gather evidence of the student's attainment for the purpose of saying whether they passed or not, what kind of degree they get. And quite often, when assessment is summative, you have to introduce all sorts of constraints, because you have to really assume the worst about the student. We have lots of meetings where we talk about how students could game the system, or ways in which they could cheat, which leads to quite stripped down assessments, where you want a predictable result and you want a robust result, and that really constrains what you can do. When you're providing formative material which is for the students' learning, you can trust them a bit more, because they're accessing this for their own benefit, which means you can be a bit looser with some things. It doesn't really matter exactly how the marking works. What is important is that you're helping to build the student's understanding. And you can do that by feedback, or you could do that by offering them some kind of activity that gives them something to think about. So I'm going to show you some ways you can do that in Numbas. I've tried to make them some things that don't take too long to set up. I spent yesterday making these slides, the questions that I'm going to show you in this talk. So once you've gone past the learning curve of learning how the systems work, it shouldn't take too long to get up to the level where you can make these kinds of things in not much time as well. Right. So straight on. I'm going to show you some big ideas about what I think formative assessment can be good for. The first idea is feedback loops. The idea that as a student, you do something, you get some feedback, you can respond to it, and that goes in a loop. If you've played the game Wordle, that's a good example of a feedback loop, because you write in a word, you get some feedback about which letters are correct, and you use that to make another guess. So what kinds of things can you do with a computer? Here's a question that's fairly straightforward, and what I want to show you here is the most immediate and most obvious kind of feedback loop is I enter an answer and the system tells me if I'm correct or not. That can be useful, but it doesn't help me too much. So I'm shown here, calculate the product from I equals 1 to 5 of 2i. How do I work that out? I have to do some thinking. I might come up with an answer. What happens if I get it wrong? I don't know what a plausible incorrect answer is here. Now, I've entered an answer here, and some value has been provided by the system. It has told me that's wrong. So if I was confident that I had the right answer, I now have to think, do something else. You can improve on that a little bit by expecting some kinds of answers that the student will put in for particular mistakes you might expect them to make. So here, if I'd added up the terms here, I would get 30. So when the student writes that, you can give them some feedback saying, I think you added the terms instead of multiplying them. The pi sign means multiply the terms together. So that's a really basic bit of feedback. Another feedback loop you can have, again, these are examples where you're getting feedback after submitting an answer. There are other kinds I'll show you later. In this question, I'm shown a quite complicated expression. F of x is 5 sine minus x minus 2x squared plus 10, and I'm asked to find a root of that function. So a point where it's 0 to 3 decimal places. And the feedback I'm going to get is, and I might have added some explanatory text if I was showing this to a real student, is that I will be shown the value of f of x when I put x in. So if I put x is 1 here, I get told that f of x is 3 point something something, refine your answer and try again. I can use this interactively to try and find the root. When x is 2, it's switched to negative, and I'll use what I know about finding roots to try and home in on that. It's going to be somewhere around here, 1.55. Now, I foolishly randomized these so I couldn't practice this. So I'm trying lots of different inputs, and really quickly, the computer is telling me the answer. If I was doing this on paper, there would be lots of slow calculations in between each step, which really aren't the point. And those are opportunities for mistakes. I'm using the computer as an assistant to help me go through this. We wouldn't do this in a summative assessment because well, we might. You're getting a lot of help from the computer here, and we have no way of assessing how much thought went into the answers here. But I'm having to do some thinking as someone using this formatively. How do I pick the next thing to put in? This is a feedback loop as an assistant. Here's another example of this. This is a bit more like the Wordle example I said at the beginning. I've got to write a number congruent to some things modulo these bases. And the feedback I'll get when I enter an answer, I'm going to go with 2 first of all and satisfy the first line of that. I will be told for each of those things whether it's congruent to the right thing. I've got very lucky there. I've got the first 2 satisfied straight away, and then I know that I can add on multiples of, I guess, 24 to this, so 26 plus another 24, was it 50? And keep going until eventually I get to, what am I doing? 98, yeah, satisfy all of those. So again, there was a feedback loop there. And you could expand this by maybe offering some suggestions about what you might try next, what you might try to add on. So those are some simple examples. Something else you can do with online assessment is to allow the student to explore. You can offer them a choice of paths through an activity. A really, really simple and very easy to implement example of that is just offering a choice of hints. This is a really made up example. There's functionally no task here. I have to write that number down, but the point is to show off the structure. If you've got something complicated to do, you could offer the student a hint. But by offering different levels of hint, you can allow the student to say, well, I need a little bit of help getting going. I might want a vague hint to give me the structure of what I need to do. Or if they sat and thought about it for a long time, they might actually want to be guided through step by step. This is what you do for this and this and this. So this model it is quite common across assessment systems. I've seen this in Isaac Physics recently. It's quite good. So that's a really simple means of offering students some choices, which you couldn't do with a written assessment. I don't think you couldn't. Well, I guess you could hand the student a piece of paper and say, don't look at this one until you're really stuck. But this is quite straightforward to do online. Another kind of exploration is you can have the computer work as an oracle. I guess this is similar to the modular arithmetic question up above. This is a question where it's group theory. This is a question we have with our, I think, stage 2 students. So we've got the binary tree here, and we've got the symmetries of that tree, and each of these letters represents a reflection in the line coming underneath it. So down at the leaves of the tree, I've got the numbers 1 to 8, and each node in the tree up there is labeled with a different letter. So I can offer the student a box where they can type a word and representing a series of moves to make, and it shows you what that does to the tree. And I'm realizing now that I haven't updated my slides with the latest version of this question, so you're going to see some debug stuff. So if I type A here, imagine that you see another copy of that diagram. So that I didn't do that, but anyway, it tells me if I do A, it swaps those things around and produces this ordering. And again, I can use this. I can say, what does AA do? Oh, well, it produces the same thing again. What about AB, AB? That's not, that doesn't produce what exactly the original permutation. So that's a nice thing you can offer the student to then help them answer other parts of the question. So like this, write a word produces this ordering. It's hard to do this on paper, and you might make mistakes. So having the ability to get some feedback from the computer telling you where you've gone wrong, that is really helpful. Finally, not finally, almost finally, another thing you can do is offer the student a choice of techniques for solving, for working through a problem. This is really helpful when you've got an algorithm and there are a couple of different ways of doing it. This question's about binary encoding, even though it doesn't look like it yet. And I can pick the number I put in. That's a good choice to give a student. So I want to write this in binary, and I've got a couple of different ways of doing that. Repeatedly subtract the largest possible power of 2, or subtract one of its odd and then divide by 2 repeatedly until we get down to nothing. Those are 2 different ways of finding the binary representation of a number. Or finally, I'll say I can use my own method, and it's going to just show me a button to, an input box to enter the binary encoding and mark it. So that initial kind of feedback we had earlier. So what this do is it will help me guide me through step by step through this process. So I've gone with repeatedly subtracting powers of 2. So it'll assess each of those steps. And getting feedback at each step along the way helps me differentiate between, am I doing the wrong thing, or have I made a calculation error? And that's really helpful. And that's, again, something that's hard to do on paper, but easy to do online. I'm going very quickly, and I can see Michael's just hoving into view. So I'll skip that one. Finally, I think I said in the abstract for this talk that there would be some diagrams. I think it's really useful to have diagrams, and having interactive diagrams online it's kind of like are manipulative. In schools, kids quite often they're given blocks to work with, and thinking about things in a graphical or physical sense is really valuable. So here I've got a Venn diagram. I can drag these points. I want to say, are they in the set of positive numbers and the set of even numbers? And I can get some feedback on that. So I'll move these around. I don't have any in the intersection, and I have some outside there, and I can submit, and I get marks on that. So those are some things you can do. A really quick snapshot of some ideas. I hope that's of interest. There's a Numbas website, there's a Numbas email address. You can talk to us. Check it out if you are interested in that. Thank you.
Brilliant. Thank you, Christian. I think virtual quick round of applause there for Christian. Bernard, I see you've got a question in there. So, and I think you've got your hand up. So if you'd like to kind of come in and quickly ask that to Christian, I think that's a really good question. So Bernard, if you would like to come in.
So as I said in the chat, I have used it, Numbas, I love it, but I have to say two things. It's quite a bit of work. So I see one question to do that properly is at least as much as doing an exam question together with a full solution in terms of work. And I think some of that work is duplicated because there's a lot of good stuff out there, which I found not so easy to understand. So there was a nice solution to a GCD algorithm. I used it as was, but I didn't really understand how it was typeset and with all the tables and so on. So I wonder whether we could have some system, maybe it exists already, that would rate a really good solution, a highly worked out solution that one could then copy, because then that would reduce the work that one has to do to amend it. So that's my question, because the good work there is excellent, but it seems to be there's too much duplication that might be avoidable.
Yeah, thanks. Yeah, it does take lots of time to write these, and that was a point I wanted to make, that I think these things are worth the investment to make these. It's certainly not worth wasting your time duplicating effort. We are trying to put together an open access library of well put together questions that have been reviewed. Work on that is slow because we've got a million other things to do at the same time. But yeah, that's definitely something I'm aware of as a problem, and we're trying to work on and could do with some help with. If you have some time to review questions in the public database, get in touch.
So maybe it could be self-organized, like on Stack Overflow, where people can actually rate, say, well, this is a great one, and others are moving further down the list, because it's really great what's already out there. So yeah. Well, that was my comment. Thank you.
Thanks.
Thanks, Bernard, and thank you, Christian.